Okay, we're going to look at some problems from section 2.1, some transformations of quadratic functions. But one of the things that we're going to do, we're going to start with a little review. Remember, standard form for a quadratic equation is y equals ax squared plus bx plus c, provided a does not equal 0. But we also have this vertex or graphing form that we talked about. And that is y equals a times x minus h squared plus k. Sometimes you'll see it written as y minus k equals a times x minus h squared. But we'll use this version since this is what our textbook uses. You can see here all it is subtracting k from both sides. Okay, so we start with the premise that our parent function is y equals x squared. And then we have either x minus h squared or x plus h squared. And so this moves the graph, and we're talking about specifically moving the vertex. So here, a quick sketch. Right, there's our vertex. So this is the point that we're talking about moving. So this moves the graph h units to the right. This moves the graph h units to the left. Plus k moves the graph k units up. Minus k will move the graph k units down. And then we have the a, which is our stretch factor. If a is greater than 0, then we face up or open up like that. If a is less than 0, then it faces down or opens down. Will look like that. If a is less than -1 or greater than +1, then the graph is narrower. And if a is between -1 and 1, and again not equal to 0, then the graph is wider. So there's a little overview. So now let's look at a couple of examples. So here we have f of x, we're using just function notation here, equals 2 times x minus 4 squared minus 8. So we're going to go through each piece. So the x minus 4 squared, so moves the graph 4 units to the right. The minus 8 moves the graph, moves it 8 units down, and the 2 makes the graph narrower. So there are our transformations. So again, here's our graph. So instead of the vertex being at the origin as it is for the parent graph x squared, we're going to go 4 units to the right and 8 units down. So there's our vertex. Because a is positive, we know that the graph will open up. So we're going to use the method that we talked about yesterday in terms of finding other points. So if I go left 1 or right 1, normally would go up 1 squared, which is 1, but because of the 2 leading coefficient, we're going to multiply that by 2. So I go left 1 up 2 times 1 squared, or 2. Same thing to the right, our point of symmetry. If I go left 2, I would go up 2 squared times R2, our leading coefficient. So 2 squared is 4, times 2 is 8. So I'm going to go up 8, which ends up giving us an x-intercept. Same to the right. I go to the right 2, up 2 squared times the leading coefficient of 2. If we were going to go left 3, we would go up 3 squared times 2, which is 18. So we could actually do that here on this graph. So 3 to the left, 1, 2, 3, up 3 squared 9 times 2 is 18, which would take us up to 10. And the same thing if I went right 3, 1, 2, 3, I would go up. And so we actually have a little bit more than 5 points. Obviously here we did 7. And so the best of our ability, we're trying to draw that nice smooth curve. And hopefully that looks a little bit narrower than the regular y equals x squared. Okay, let's look at one more. Here we have the x plus 2 squared. And so that moves the graph 2 units left. The plus 3 moves the graph 3 units up. And the negative 1/3 has 2 effects. It will open down, and it will be wider. Okay, so I'm going to use the same set of axes here. So we're going to go 2 to the left and 3 up. So there's our vertex. And now we're going to find other points. I'm going to try a different way here. I'm going to find some x-intercepts. I'm going to substitute 0 here for g of x. Subtract 3. Multiply both sides by the negative 1/3. Divide by negative 1/3 or multiply by the reciprocal of negative 3. So that gives us 9. So here's one of our big topics for the year. We're going to take the square root, and the square root of 9 is 3. And anytime we take the square root of a quantity squared, that gives us the absolute value of that quantity. One of our new topics for this year. So now, to solve an absolute value equation, we're going to take the x plus 2 equal to 3 and negative 3. And so we end up with 1 and negative 5. So 1, 0, and negative 5, 0. So there's our 1, 0, and negative 5, 0. You can already see we're getting a little bit wider there. And then I'm going to use 4 as another x coordinate. I'm going to find g of 4. So negative 1/3, 4 plus 2 squared plus 3. That's 6. So negative 1/3, 6 squared is 36. That would be negative 12 plus 3, or negative 9. So we have the point 4, negative 9. So here's 4, negative 9. And then using the concept again of point of symmetry. So here I'm at negative 2. To go to 4, I went 6 units to the left, or the right rather, 6 units to the right. So I'm going to go 6 units to the left. That would take me to negative 8. And I'll go down to the negative 9. And so we have that symmetrical point. And again, we're going to do the best job that we can of trying to draw a nice, smooth curve, a nice U-shaped parabola. And there we go. So there you have, again, you can see it's clearly that one's wider than that one in the negative 1/3. The negative made it upside down, and the 1/3 made it wider. So hopefully that helps.